So in the rest of this lesson, what we're going to look at is bond polarity and intermolecular forces. So we're going to look at what happens when we make these bonds, okay? When we make these bonds, and the intermolecular forces are what's holding the bonds together. So the fact that we have covalent and ionic bonds, and there's electrostatic charges holding ionic bonds together, and we're sharing in covalent bonds. When we do that, we kind of make a charge on our molecular compound. That charge is then going to help us to figure out what kind of intermolecular forces is going to kind of help to attract other molecules to itself. So you know that a bottle of water is not one molecule of water. It's billions upon billions kind of stuck together. That stuck togetherness is that intermolecular force. There's something holding all of those molecules together. So intra is inside, it's inside the actual molecule. Inter is what's holding other molecules close to it. So we're going to take a look at that. So first thing to remember is electronegativity. That's the ability to attract an electron to itself. Non-metals are going to be higher and our metals are going to be lower in electronegativity, because remember that it increases as you go left to right, and it increases as you go from the bottom to the top. Okay, so the most electronegative element that we have is fluorine. Okay, so fluorine is going to be the most electronegative, and francium is going to be one of the least electronegatives. When we're looking at ionic bonds, again, that's electrons being being taken or given between metals and nonmetals. So that's the steel part of our bonding. Your electronegativity is not greater. It's greater than 1.7, but not greater than 2. Okay. If it is polar covalent, that means we're going to share electrons. So these are dealing with covalent compounds, and the electronegativity is going to be between 0 and 0.5 and 2. Okay. The higher the En will be slightly negative. The lower the N will be slightly positive. So so if you're close to 2, you're going to have a slightly negative charge. If you're close to 0.5, it's going to be slightly positive. Okay, and then nonpolar, the electrons are going to be shared equally. Okay, we see this a lot when things like diatomic elements are elements that are the same element attached to itself. So hydrogen attaching to hydrogen becomes H2. Okay, electronegativity is going to be less than 0.5. Okay, less than 0.5. Okay, so again, that intramolecular is going to hold our compound together. Okay? And that's the ionic or covalent. These are strong. It's really hard to break an intramolecular force. Okay, that's why you have very highly reactive chemical reactions, because it takes a lot of energy to break intramolecular forces. Intermolecular forces are what's holding the compound to another thing. We call them IMFs, and they're kind of weak. It's really easy to kind of put your hand through a thing of water and for it to move, okay, for it to break down. Okay, so the first one is London dispersion. Okay, it's between all molecules. So every time you have a molecule attaching to another molecule, it'll have some sort of London dispersion in it. Most notably, though, it's going to be a lot of non-polar molecules. It's caused by the random movement of the electrons. Remember, electrons are still moving in the atom, and because they're moving into different spaces, they're going to cause part of the atom to be negative for just a second. So the top part might be negative for a second, the bottom part might be positive for a second. And because of that, they're creating what's called a dipole. So you have one side negative, one side positive. Because that is happening, a positive is going to are going to be attracted to the negative side. The more electrons, the stronger the London dispersion forces are going to be. But it is still the weakest of all the intermolecular forces. Your next is you're going to have a dipole-dipole. So a dipole, again, is when your elements have a negative side and a positive side. So these are charges, okay? And it's not from losing electrons like in ionic compounds or ionic bonding. This is just the fact that the electrons are going to be on one side of the more on one side of the molecule than the other. And this happens between polar molecules. And these dipoles are going to be permanent. So the electrons are going to really stay on this side more. And we're going to have that attraction again. So a positive side is going to be attracted to a negative side of another molecule, and they're going to come together. They're stronger than London dispersion forces, but they're not the strongest. So they're the middle. So you have your London dispersion, your dipole, and then you're going to get this last one, which is hydrogen bonds. And this is a special type of dipole. So it's a dipole, but it only occurs when you have hydrogen and you bond it to oxygen, nitrogen, or fluorine. So if you have a hydrogen attached to a fluorine, a hydrogen attached to an oxygen, hydrogen attached to a nitrogen, you could make hydrogen bonds. This is the strongest of our 3 IMFs. Okay, and again, this bond is the fact that you are attracted at each HF molecule, okay, is attracted to another HF molecule, okay, or a water molecule is attracted to another water molecule. The whole molecule, not within it. That's completely different. So make sure you're understanding. It just helps us just to know that the hydrogen bond only occurs in molecules that have hydrogen and then the other 3, fluorine, nitrogen, or oxygen. Weaker IMFs, they're going to have lower melting points and boiling points. They're normally in gas phases, and they're going to have a high vapor pressure. And then the strong are going to be the opposite. So lower vapor pressure, higher melting and boiling point, and normally in the liquid or solid state. So that's IMFs. Again, these are just the things that are helping our molecules kind of come together and stay together so you can actually make bigger things. So we've taken atoms, we've made compounds and molecules. Now we're taking molecules and making them into more things. Okay, so that's the way to kind of look at all of these different things and the pathway to bonding.